Okay, take two. Okay, we're talking about trigonometric ratios. This is unit 7.6. Okay, and trigonometric ratios. Tri is for triangle, metric or metry is for measurement. Okay, so trigonometry is going to help us find missing sides and or missing angles of a right triangle. Okay, so trigonometry, we're going to use right triangles. We good? Okay, and sorry, I'm off screen. I know you're not. Okay, if you notice, we're looking at angle A here. The leg that's opposite angle A, is facing angle A but not touching it, is BC. The adjacent leg, it's touching it, okay, right next to it, touching it is AC. And Harry the hypotenuse is AB. No matter which angle we're looking at, A or B, the hypotenuse is always going to be the hypotenuse. You can call him Harry, because I do. Okay, so, and it's called sine, cosine, and tangent. They're just names for ratios, fractions. Okay, so the sine of angle A is equal to the length of the opposite leg divided by the hypotenuse. So sine is opposite leg divided by the hypotenuse. This is a way to remember it. Cosine is the adjacent side divided by Harry the hypotenuse. And tangent is the opposite side divided by the adjacent side. So the way to remember it is SOHCAHTOA. Oh, hello, I have to fix that. I don't know what I did there, but okay. Okay, so it's SOHCAHTOA. That's how you remember the trigonometric ratios. All right, let's move on. Okay, same thing. But now check this out, okay? So they gave us two triangles here, and if you realize that they are similar, okay, because 5 times 2 is 10, 4 times 2 is 8, 3 times 2 is 6, so they are similar because the sides are in proportion. And if you notice, the angles are equal. So the corresponding ratios are going to be equal. Check this out, okay? So if you do BC divided by AB, that's the sine, okay? If you do BC divided by AB, it's going to be the same thing as EF divided by DE. They all reduce the same. Watch, watch, watch. Okay, I'm going to do it over here. I'm hiding. So let's do 3 over 5 and 6 over 8. I want to reduce 6 over 8 to lowest terms, and they're both even, so I can divide by 2. 6 divided by 2 is 3. I have to learn to write, though. 6 over 10. Oh, my goodness. And what's 10 divided by 2? Yes? Excuse the mistakes. Okay? So look, 6 over 10 is equal to 3 over 5. 3 over 5. Okay, any multiple is going to work. Okay? And we're going to talk a lot about these, so no stressing. Okay, what are the sine, cosine, and tangent of A? I am going to write SOHCAHTOA. Okay, so SOHCAHTOA. Okay? So now, first thing I want is the sine of angle A, and I'm marking the angle I'm using to make my life easier. Okay, so the sine of angle A is going to equal the opposite side over the hypotenuse. All right, the cosine of angle A is, so the cosine is equal to the adjacent side over the hypotenuse. The connected side here is 4 over Harry the hypotenuse is 5. And now the tangent, and the tangent is the tangent is the only thing that can come out greater than 1. Okay, so here the tangent is the opposite side over the adjacent side. So tan A is equal to the opposite side, which is 3, over the adjacent side, which is 4. I don't know why I wrote it like that, but I did. So we're all good. Okay, let's go to the next page. Oh, and there, proved it to ourselves. Okay, now we're looking at angle B. Notice before we looked at angle A, now we're looking at B. Okay, and I'm going to write soak a toe again. I'm going to soak my toes. Okay, so I wrote it again. Now, so I'm looking at angle B. I want the sine. So the sine of angle B. Okay, remember, sine is opposite side over hypotenuse. So it's going to be 4 over 5. Okay, I want the cosine of B. Okay, cosine equals the adjacent or connected side divided by the hypotenuse. Okay, so it's going to equal, where am I? Oh, well, I'm looking at cosine A, so ignore me. All right, so the cosine of B is the adjacent side, which we all agree is 3, over the hypotenuse, which is 5. Okay, the tangent of angle B. Remember, we're looking at angle B. It's the opposite over the adjacent. The opposite over the adjacent. Okay, so it's going to equal 4 over 3. And you notice the fraction 4/3 is greater than 1. Tangent is the only thing that can be greater than 1. Okay? Yeah. Okay, and there's our answers. Okay, calculate cosine, sine, cosine, and tangent of 40. You're going to need your calculators for this. Now here, they only went to 3 decimal places. Get in the habit of going to 4. Okay, so on your calculator, you would hit sine 40, and then I would close the parentheses. Okay, and you're going to come up with what they have here. Then cosine 40, and then tangent 40. Okay? So again, they went out to 3 decimal places. I don't know why. We should go to 4. Okay, and here's a chart. And I want you to look at something. Okay? I want you to look at, you ready? Look at the measurements for a 10-degree angle and look for an 80-degree angle. There is a method to my madness, though madness it may be. Okay? So look at the sine. Where am I? Look at the sine of angle A. And look at the cosine of its complement. Okay, 80 plus 10 is 90. Look, look, look. They're the same. So the sine of a 10-degree angle, look at this. Sine of a 10-degree angle is equal to the cosine of an 80-degree angle. All right, let's look at that another way. Let's look at 40 and 50. Okay? So we're going to look at the cosine of 40 because I feel like it. All right, so the cosine of 40 and look at the sine of 50. OMG. So the cosine of 40 equals the sine of 50. And 40 and 50 equal 90. So the sine of an angle is equal to the cosine of its complement. Okay, and I'm going to stop here because I don't want it to be too long. And we will continue in another one.